All we're working on today is this first icon. We are defining the trig ratios. I don't know if any of you have ever heard them before, but they are sine, cosine, and tangent.
Oh,
You remember
those
this?
like buttons on the calculator?
Yeah, the buttons on the calculator. Sine. It's not sin, FYI. Sine. It's not cos, it's cosine. It's not tan, it's tangent. But anyway. Alright, so sine is defined by two sides. Sine, not sin, sine. What you do is you take the opposite and the hypotenuse. So hypotenuse shouldn't be a new word, right? What's the hypotenuse? The diagonal, the one that's across from our right angle. So no matter what ratio you're working with, that C will always be your hypotenuse. Okay? Your opposite depends on what your angle is. If you look at this first one, it says take the sine of angle A. So next to sine, cosine, and tangent, these letters are always angle measures. Because you can't take the sine of like a side length. Just chill. You have to take the sine, cosine, tangent, or of an angle. Okay? So here's angle A, right? And to find the sine of it, you take the opposite side. Well, what do you think is opposite of A? If C is our hypotenuse, what do you think is opposite that angle?
The lowercase a.
The lowercase a. You know it's opposite if it doesn't touch it. So you see how this side A doesn't touch that angle? That's how you know it's opposite. So to find the sine of angle A, we're literally going to take that lowercase a side and divide by our hypotenuse, which we said is always C. Later on we'll get to numbers, so this will make more sense. But that's all it is. It's just a ratio of sides. If I want to take the sine of angle B, here's angle B. What side is opposite that angle B? The little b. This little b doesn't touch it. So the opposite would be little b. And what's my hypotenuse? C. Always the same hypotenuse. Always that little c.
Sorry, I couldn't hear you. Could you please repeat?
So sine opposite over hypotenuse. Okay? Well, this other ratio called the cosine. The cosine, you're going to take the adjacent side. Adjacent means next to, right? Like when we had adjacent angles. And again, the hypotenuse. So the hypotenuse is going to be the same, in this case, C. The adjacent will change depending on what angle you're looking at, though. So I have the cosine of A, so this angle A. We know C is our hypotenuse. We said lowercase a was our opposite, so that makes this side right here the adjacent side. The adjacent side should touch your angle, and then your hypotenuse. It's just super important that you always pick out your hypotenuse, because the hypotenuse is also like an adjacent. It's next to our angle, but it always has a special term. It's the hypotenuse. It's not just a regular side, it's the hypotenuse. So to find the cosine of A, it's just that little side B divided by the side C. So it's this adjacent B over the hypotenuse C. If I'm looking from B's point of view, I still have C as my hypotenuse, but what side's next to it? That's not the hypotenuse. A. So this is my adjacent side, and this is my hypotenuse. So to find the cosine of B, we have that little a over the hypotenuse C. Tangent is the one we will use a lot in word problems. It is the ratio of the opposite side over the adjacent side. Okay, so if I'm looking at angle A, what side did we say was opposite angle A? Little a. What side did we say was adjacent? little b. So to find the tangent, you're going to take little a over little b. Notice this one you're not using your hypotenuse at all. And then for the tangent of angle B, what is my opposite side to angle B? Little b. And what is the adjacent side to angle B? Little a. So we're using the same two sides, but this one is like a flipped version. Okay, so it's super important that you look at whatever angle you have. So you can't just pick any angle, you have to give the one that you're being told. Okay, let's throw numbers in there, and I feel like it'll make a little more sense. We have this little saying. The saying goes, so, ka, toa. And we use those letters specifically because they mean something. The so, S-O-H, the so stands for sine equals your opposite over your hypotenuse. So to find sine, you take your opposite over hypotenuse, your so. The ka is your cosine, stands for your adjacent over your hypotenuse. Again, C-A-H, cosine, stands for your adjacent over your hypotenuse. I would write this down. TOA stands for tangent, is your opposite over your adjacent. So TOA, T-O-A, is your tangent equal to your opposite over your adjacent. That is a little trick that we will use probably the rest of the chapter. Alright, so now we got numbers. I want to find the sine of A. Here's my angle A. Sine stands for opposite over hypotenuse. What number is opposite A? 5. What's my hypotenuse? 13. You always want to make sure that you are talking in like simplest terms. So can I reduce 5 over 13? No. So sine 5 over 13, opposite over hypotenuse. If I want to find the cosine of A, cosine is my adjacent over my hypotenuse. What number is adjacent to this angle? 12. And my hypotenuse again is 13. The tangent is opposite over adjacent, so looking at that angle A again, it tells me which one's opposite. 5. Which one is adjacent? 12. And I can't reduce any of those, right? Yeah. Okay, if I look from C's point of view, because now it says look at angle C, so this is the one I'm looking at. Asked for sine. Sine is what over what? Opposite over hypotenuse. What's opposite C? 12. So here's my opposite. What else do I need? Hypotenuse, which is 13. So to find sine, I'm going to take 12 over 13. To find my cosine of that angle, what's adjacent over hypotenuse? What's adjacent? The 5, the only one that's not labeled yet. So I'm going to take 5 over what? 13, because that's my hypotenuse. The tangent is opposite over adjacent. So which one's opposite C? 12. What's one adjacent? 5. 12 over 5. questions so far? Okay. Next one says find the sine of W. Sine is what over what? Am I missing anything? Yeah, my hypotenuse. It's blank. How can I find my hypotenuse? Yes, Pythagorean theorem. Perfect. 9 squared plus 12 squared equals my hypotenuse squared. 81 plus 144 is? What do we get? 225. How do I figure out what x is? Square root it. What is the square root of 225?
15.
Perfect. So this side is
Why did I
15.
get a guess on that?
Why did I guess that?
No, I said my owl because I put the wrong number.
Alright. So from W's point of view, to find sine, you said we need what over what? Opposite over hypotenuse. What's opposite W? 12. What's my hypotenuse? So I'm going to take 12 over 15. Can I reduce that fraction? Yeah. 3 goes into both of them. How many times 3 go into 12? How many times 3 go into 15? So 4 over 5. The cosine is what over what? In words. Adjacent over hypotenuse. Which one's adjacent? The 9. So I'm going to take numbers what over what? 9 over 15. Can I reduce that fraction? Yeah. 3 goes in there again. 3 fifths. Tangent in words, my TOA is what over what? Opposite over adjacent. So in this case, numbers 12 over 9, which is 4/3.
So if we get improper fractions, you want us to leave them improper, or?
Yeah. Oops, I erased my 15. I'm sorry. Yeah, impropers are okay. Alright, now we are looking from X's point of view. So you don't have the same opposite and adjacent, alright? That's why I erased those. Because now my sine, my opposite of hypotenuse, what's now opposite that X? 9. So it's not the 12 like I had before, it's this 9. My hypotenuse, however, doesn't change. What's my hypotenuse? 15. 9 over 15 is 3 over 5. Cosine, my cosine is adjacent over hypotenuse. What's adjacent? 12. So I get what over what? 12 over 15. So 4 over 5, is that what you said? That's 4. Sorry. I'm sorry. TOA, last one, tangent, is opposite over adjacent to TOA. So what over what? 9 over 12. Simplify. 3 over 4. So what do you notice about the ratios for angle W and angle X? Yeah, which ones are flipped?
And they're opposite, not opposite.
Not opposite, but just reciprocals. Which which ones match? The tans. So we notice that tans are flipped. What do you notice about the sines and cosines?
Oh, they're different. They're the same, but just for different.
Yeah, so my sine of W is 4 over 5, which matches what?
Your cosine.
My cosine of X is 4 over 5. Well, that kind of makes sense, right? Because what's opposite to one angle, like this was opposite over hypotenuse for my W. Well, for my X, it's adjacent. So we notice that sine of W and cosine of X match works the same for sine of x and cosine of w. Well, what do you know about angle w and angle x? Think about how many degrees are in a triangle. How many degrees? Not necessarily. There's how many degrees in a triangle? 180. If this is 90, how much is left for these two? I take my 180, that's in a triangle, subtract out that right angle. They're 90. What do you know? What do we call angles that add up to 90? Complementary. They are complementary angles. They add up to 90 degrees.